Alrighty, so we're going to go through the solutions for our volume by washers problem set. And we're starting with number 3. Okay, so 3, they are actually pretty nice. They give us the graph, so it's radical x, but we're only looking at this from 1 to 4. Okay, we're going around the x-axis. So I'm going to draw my rectangle perpendicular to the axis of revolution. And we know that the volume is going to be equal to pi times the integral from a to b of big R squared minus little r squared dx. So pi, a to b, the interval is 1 to 4. Big R is from the axis of revolution to the far end of the rectangle. That's our large radius, and that's radical x, and then we square it. Little r is the distance from the closer end of the rectangle to the axis of revolution. That's what creates our hole in our washers, but we don't have a hole there, so the inner radius is 0. That means that this is actually a disc instead of a washer. But same method, we have pi times the integral from 1 to 4 of, whoops, I don't know why I have an equal sign there, of x dx. And we can put that in our calculator, but for some reason I feel like doing this by hand. It's just so little. Hope we need a pi there. So I've got pi over 2 times 16 minus 1 is 15 pi over 2. Okay, number 5. Number 5, they also give us the graph, but it's 2 different functions. I'm not going to do a good job drawing this. Let's see. So we've got one function here and another function that kind of goes below it and then crosses up. All right, I didn't do a terrible job, I guess. Okay, so the one on top, the red one, is y equals x squared. And then my blue guy here is y equals x to the 5th. So they tell us that the point of intersection right here is 1. So going around the x-axis, here is my rectangle. Volume equals pi times the integral from a to b of big R squared minus little r squared. Pi, we're going from 0 to 1. Big R is the distance from the far end of the rectangle to the axis of revolution, and that's x squared. Little r is the distance from the near end, the closer end of the axis of revolution to the axis, and that is our x to the 5th. And we're squaring that. So I'm going to simplify this just a little bit to make it easier to put in my calculator. X to the 4th, x to the 10 dx. And we put that in, and you should get 65 or 6 pi over 55. And that's that. Okay, moving on to the next one. Number 7. Number 7, they change things up a little bit. They still give us the graph, which is very nice of them. We've got part of y equals x squared, this region here. But now this time we are going around the y-axis, so we're going to have horizontal rectangles. So that's going to change everything so that we're in terms of y. So pi a to b, r squared, but dy. So pi, our y values are now 0 to 4, because this guy up here is 4. Big R is the distance from the axis of revolution to the far end of the rectangle, and that's being given by our function, by our parabola. But it's written in terms of x. If we solve for x, we're going to get plus or minus radical y. And since this is the first quadrant and not the second quadrant, we're using the positive value, the positive root. So big R is radical y squared. Little r, it looks like there's no, or little r is 0, because there's no gap between the axis of revolution and the other end of the rectangle. So that's going to give us a disk instead of our washer. So pi 0 to 4 of just y. And let's see. I'm going to do this one by hand also. So I'm going to have 1/2 y squared from 0 to 4. So that's pi over 2 times 16. I'm not going to plug in the 0 because that'll just be 0. So we end up with 8 pi. You should get the same thing if you used your calculator. 9. 9 is similar to 7 because we are going around the y-axis. So let's see, this is our region now. And on the y-axis, so we draw our rectangles horizontally, which means that everything will be in terms of y. So volume equals pi a to b of big R minus little r dy. 0 to 1, remember everything's y values. Big R is the distance from the axis of revolution to the far end of the rectangle. So that's being given by the function, which is x to the 2/3. That's in terms of x. If we solve for x, it's y to the 3/2. Little r, once again, is going to be 0 here because there's no distance between the other end of the rectangle and the axis of revolution. So we have a disk. So pi 0 to 1 of y, let's see, it's just y cubed. And that, again, is also not a big deal to do by hand. So 1/4 y to the 4th, 0 to 1. If we plug in 1, I'm going to get pi over 4.